This is my project mixed master workflow. First, I'm going to demonstrate that my code compiles without warnings or errors. As you can see, my code compiles without warnings or errors. Next, I'm going to show an example of definition and the redefinition of variables. So I will define A as hello and B as world. Then I'm going to echo these two variables and I'm expect to get hello world printed. And this is true. Now I'm going to redefine variable B to 209 and call echo A and B again, and then I should get hello 209. And as you can see, it is correct. Next, I'm going to demonstrate that an example where a variable is extended within the definition of another variable. Now I'm going to define variable C as CSC, and I'm going to put B inside it. So I'm expecting that C will be CSC 209. Now I'm going to call echo A and C, and I should get hello CSC 209. And let's see. As you can see, my code is correct. I implemented variable storage using two structs as defined in variable.a. Uh, the variable struct stores the variable array and its information. Here, the max count is the maximum number of variables that the current array can hold, and the current count is the current number of variables in the array, and variable list is an array of variables. And another struct is the variable struct, which stores the variable name and the content inside the variable. In niche.c, I allocated a space in the heap for the variable array struct and initialized its capacity to 8. And I also allocated an array of variables based on this capacity. In variable.c, this is where variable assignment is handled using the setVariable function, which takes as arguments a pointer to the variable array struct and the assignment line. This function checks three conditions. First, if the variable array is at its maximum capacity, then doubles the size of the array. Second, if the variable already exists, then the variable is redefined based on the variable uh, assignment statement. Third, if the variable name is new, then it is defined based on the assignment statement. The advantage of my approach is that since all the variables are stored in the heap, I can easily define and redefine the variables. Even if the variable list is full, I can always expand the size of the variable array and continue storing new variables. However, there are drawbacks in my approach. First, the size of variable array is always to the power of 2. That is, like, it can be 8, 16, 32, 64, and more. And say if the variables, say if the available space in the heap is, let's say 511 variables, then I can only allocate a variable array of 256 variables and wasting almost half of the heap. There is another approach that I've considered when I was implementing this feature. That is using a linked list instead of array. If I had used a linked list, then almost all space on the heap can be used. However, traversing through a linked list is terrible. Since to look up or add a variable, we need to traverse whole list. In my opinion, accessing time is more important. Therefore, I choose a dynamic array. My approach, I expanded variables right after getting input from standard in the function get input. The expand function takes as arguments an input string and a pointer to the struct of variables list. And its purpose is to replace the input string by expanding it and truncating it to 128 characters. Firstly, in the function, I allocated the space in the heap to temporarily store the expanded and truncated lists. Then, my strategy is to tokenize the input string by the $sign. If there's no tokens, it means that there's no $sign in the input string, so there is no variable expansion, and the input string will remain unchanged. However, if there is a token, then there are two cases. The first case is that if the first string of the input is a $sign, and if the first character of the token is a white space, then it means that the $sign is bytes on. So the $sign and the token is added if the space allows. Otherwise, there's a variable expansion. So the expanded variable and the remaining token will be added if the space allows. And the second case is that the first token does not contain a variable expansion, so it is added normally without expansion, and if the space allows. The next while loop does similar job as the first case to all the remaining tokens. In the end, just in case, a null is added to the end of temporary input string. Then it is copied to the input string and read.
The following is an example. So I will let A be 100 O's and B be 100 I's, and I'm going to call echo $sign hello $sign A $B, and this string will be tokenized into the following tokens. So it will be echo space and then space hello space and A space and B space. Since the string doesn't start with the $sign, so this is not a variable expansion, so the first token will be just added normally. And then since there's a space in the beginning of the second token, this means that the $sign is bytes on, so the $sign will be added and space hello will be added as well. So for the third token, there is no space after $sign, so this will be a variable expansion. And since A is defined as 100 O's, so 100 O's will be added to the expanded version of the input string. And since this doesn't exceed the limit, so it will be added normally. And then the last token B, there's no space in the beginning of the token, so this will be treated as a variable expansion as well. But since B is defined as 100 I's, this will exceed the limit, so it will be truncated. And so the final version will be echo $sign hello and then 100 O's and 13 eyes, bringing total of 108 characters, including the new line symbol.
The advantage of my approach is that I can make sure that each time adding to the temporary input string, the content will be truncated if it exceeds the limit. Therefore, the final expanded input string will be always less than or equal to 128 characters. However, there's a drawback, which is that by adding to the temporary input string each time, the code is more complicated, which makes it easier for the programmers to make mistakes. But there's another strategy that I have considered when I was implementing this feature. That is expanding all variables first, then truncate the input string to 128 characters if needed. This strategy is way easier to implement. However, it needs much larger temporary input string because there might be many variables that contain long content, uh, which will be a waste of memory resources. And that is why I do not use it. Because I think it makes more sense to save it for storing new variables instead of wasting it to just store some temporary data.